Okay, I'm going live, but I'm trying to find me. Where is me? Oh, there I am. Okay, because I'm trying to make sure that I go to my groups. So I'm going to go to I have a online class? Not online class. I do have an online class. And then I just wanted to make sure. Oh, that's a group. I don't know if I could share on a page. Okay, anyways. So, hi, my name is Lynette. Um, if you have any comments, go ahead and put them in. We're just going to be talking about Abacus and the introduction to learning how to count on the Abacus. So the first thing would be to understand um, understand how to read the Abacus. But why are we doing this? Why are we learning how to read on the Abacus? Well, it's helpful to have manipulatives. So we have different manipulatives. This is an Abacus. An Abacus helps us count and adding and subtracting and multiplication division. But first, we're going to start learning how to count. It's the same thing as understanding how to use these blocks, right? So there's these blocks where they teach us how to count. We have one, we have two, and then three squares. On the abacus, it's kind of the same. So this is my abacus. This is a teacher's abacus, and this teacher's abacus, the difference is that it's bigger. It's easier to see for distance, right? And then I have a movable marker. This marker tells us where. Oh, I gotta make sure that my mic is using the right mic. Am I using the correct mic? Uh, there's my yes. Okay, good. So this is live. If you have any questions, go ahead and put it in to the comments and I can answer your questions. So this is a marker, and this marker helps us understand where we're going to start counting. So when we count, right, we count is here. All the beads, this is the beam. This beam helps us understand where the which bead is being counted, what is being counted. So all the lower beads has a value of 1. So we count 1, 2, 3, 4. So we have 4. I don't know if you can see that. We have 4 cubes, right? So we have 4 beads. We have 4 items. And then we have 5. All the top bead has a value of 5. And then 6. So we have 5, 6, because this is a value of 1, a value of 5, and this is a value of 1. So 5, 6, 7, 8, 9. And then we go to 10. How do I know that this is 10? Well, I know this is 10 because we go by columns. The columns is a price value. So we have our ones, tens, hundreds. So this is 10, and then this is 100. So when we count, we could do 11, 12, 13, 14, and then 15, right? 15 is always the 5 up here and then the 1 here. So we have 25, and then 35, and then we do 36 and 46. So just like we do on this side, we can do on this side. So it's the ones and the tens. And then that's counting on the abacus. Okay, so I'm going to switch over to this student abacus. The student abacus is interesting because it's not supposed to be up like this. It's actually supposed to lie down flat and face the students so they could see the abacus, and then they can move it. Let me change to this one. Yes. Okay. So we're going to talk a little bit about the abacus. So here is my student abacus. And on my student abacus, it's the same concept, right? We have 1, 2, 3, 4. Let's see. There we go. Is that better? Okay. Let's see. Okay. So we have 1, 2, 3, 4. And we have our manipulatives, which is these cubes, to show us what they are. 1, 2, 3, 4. So if we have on the abacus, it's kind of the same. But the difference between the abacus and these is that these are all free, flowing, right? There's no structure to it. Whereas on the abacus, it is structured. It's inside a frame. And Maybe that's better. Oh, that's not good. Okay, in use. There you go. So, there we go. Okay, so now we have five. We have five. 1, 2, 3, 4, 5. But notice on the abacus, there's not enough beads for the five. To do the five, it's the top bead. Just like how I showed you on the teacher's abacus. On the teacher's abacus, it is the same. There's the 5 bead. So then we have 6. So that's what 6 is. 1, 2, 3, 4, 5, 6. But notice I had to count it, right? 1, 2, 3, 4, 5, 6. Or I had to split it 3 and 3. I mean, it's great to have these manipulatives. It's also great to have the abacus to help support it. So we have 6 and then 7, 8, 9. And so 9, I'd have to do 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. And then we have 10. We can do 10, right? 10 and 10. Or we could do the one column, which is this. One column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what 10 is. So I'm going to move these beads. Let's see if so that's what 10 is. How do I know? Well, there's this dot here. I don't know if you can see. There's a dot. There's a dot right here. That dot tells us where our ones is. So we can do our ones here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Well, we could either use this dot or we could use this dot, right? It depends on how big your number is. I like to use this dot because this dot means I can have all of these columns. I can use all these columns. So it'd be ones, tens, hundreds, thousands, 10,000. So my number can go up to 10,000. You could do it the other way where it's ones and tens, but then you'd have more decimals. So this is the decimal side. How do I know? Well, if this is the ones, the decimal will be right here in the middle. It'll be ones, tenths, hundreds, thousands, 10,000s, and 100,000s. Wow, that's a little bit of a tongue twister. All right, so that's what that is, and so that's the difference between the dots. Well, we have another student abacus. This is a little bit bigger. The one I like to use is this one for the kids because the kids like it colorful. And so 1, 2, 3, 4. This one has 7, but this one has 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. It's kind of nice. This one's kind of nice too. The reason why is because the dot starts from the side. So you can actually have the ones here. So it'd be 1, 2, 3, 4, and then 5, 6, 7, 8, 9. And then you would have all of these columns to use to do your numbers. And that's a lot of numbers. I don't know how many numbers you're going to be using, but that's a lot of numbers. You could start from here, right? There's another dot here. I usually start right in the middle. This is a nice abacus too. Usually, these abacus is used for competition. Sometimes there's another one that's like 27 columns, and I think that one's actually used for competition abacus. There is such thing as a competition abacus. All right, let's see if that works. Come on. Let's make it a little darker. Darker? Okay. And it's the same concept. So if I'm going to start, I usually start in the middle, just to be symmetrical. And then I can count 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then 10. Same thing. It's different with this. This is a Chinese abacus. Chinese abacus. This Chinese abacus has 2 beads on top and 5 beads on the bottom. So when we look, maybe this is better. When we look, it's kind of similar, but it's a little bit redundant. So on this specific Chinese abacus, I don't have a place where it tells me. So I just can choose anywhere I want to go. So I can just choose to go here, right in the middle. So it'd be 1, 1, 2, 3. So I have 1, 2, 3, and then 4, 4, 5. This is 5, or 5. right? 1, 2, 3, 4, 5. So 5 on the Chinese abacus is this, or it could be this. So there's two ways to do 5 for the Chinese abacus. It could be here, or it could be like this. So then we have 6, 7, 8, 9, 10, right? 10 like that is on the regular abacus, but 10 on the Chinese abacus is either this or it can be this. See how it's a little redundant? So then, but don't forget, we have 10 or 10 or 10. Whereas on the this Soroban, this Japanese abacus, this is 10 and it will always be 10. How do I know? Because this is the place value of 1 and then this is the 10. So that is the difference between a Chinese abacus and a Japanese abacus. Most of the world is using the Soroban now. The Chinese abacus is a little bit out of date because it's a little redundant. So when we count, we have 5, 6. Oh no, we're at 10. So this is 10, and then 11, 12, 13, 14, 15. So this is 15 on the Soroban, and then this is 15 on the Chinese abacus. This is also 15. And then there's 16, 17, 18, 19, 20. 20. Now this is a little confusing because I know that this is 20. It's easy to see because it's 2 and a 0, but this is a little difficult to see because this is 20. How do I know? 5, 6, 7, 8, 9, 10, 10, and then 20. So you have to kind of remember where your place value is, right? This is also 20, or this is 20. Yeah. So there's three ways to do 20 on the Chinese abacus. If you have a Chinese abacus, you could do that too. And you want to work with the Soroban, you can do it this way where you just use the middle, just like that. Just like that. So it'd be the same concept. You just ignore the top and the bottom. So we could do like uh 4, 5, 6. Sorry, 4, 4, and then 5, 6, 7, 8, 9, and then 10. You're just gonna have to remember to ignore the top beats and the bottom beats. So that's a little bit about the Chinese abacus. Um, okay. So it's cool about the abacus is that you can actually it helps with supertizing. So if you notice, it helps with supertizing. How do I know? Well, if this is 4, just like on a die, right? A die, you know this is 4. This is what was going before, and then there's 6. So that's 6. So the difference is Hi, Hi, Alyssa. I hope I'm saying your name correctly. Um, so, so this is supertizing, and the supertizing is the idea of the children be able to see what um, supertizing is being able to see what the number is without counting. So here we don't need to count because we know that this is 6. On the abacus, it's the same thing. This is 6. So if I do 3, I just do 3. Now the cool thing about this is that the human brain sees objects like anything less than 5, you can actually see it and understand it. So when we do like 4, right? We know that this is 4. Um, let's see. So if we use like manipulatives like this, right? 1, 2, 3, 4, if we count it, that's fine, right? It's easy to see. But when we start adding more like this, we have how many do we have? We have to count it 1, 2, 3, 4, 5, 6. So on the abacus, it's easy to see because this is the value of 5 and this is a 6. So, so what am I trying to say is um, it's easy to supertize on the abacus. You can use a die, which is not a problem. But the problem with the die is it only goes up to 6. So if you need to do 7, right? That's 7. I would add one more of this. So I'd count it 1, 2, 3, 4, 5, 6, 7. And then this is 7. But then if I'm using a die, I need to add another die. I don't have a same die, so I got to use a different one. So you could do this. I mean, this is the introduction of supertizing. You can, right? We can change it to this, right? Which is 7, but that's a different concept altogether. Um, but then, we know that this is 4 and 3 that makes 7, but then we have 5, 5 and 2, 5 and 2. But on the abacus, it's easy to see because it's 5 and 2. If we take away the 5, we know it's 2. We add the 5, we know it's 7. So it's kind of nice to see that there's a pattern to it. If you have any questions, let me know and I will get back to you. So, um, so that's supertizing. And it's kind of cool because when we do all of this, we know that this is 9. Whereas if I gave you like this, if I did this, oh, I got to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we would have to count that this is 9, right? We'd have to count it. But here on the abacus, it's easy to see that this is 9. See, that's 9 too. But this is 90. Well, how do I know it's 90? Well, this is the ones and then this is the tens. Yeah. And this is the hundreds. So it'd be 90. This would be 900. This would be 9,000. But notice the 9 is always going to be the same. So, but yeah. Whereas if we started using these blocks, right? These are common blocks for kindergarten. So we have these blocks. It's great. These blocks are great to show the actual quantity, but it's a little bit difficult to maneuver, right? The idea is once they understand that there's quantities, then they have to go into place value. Abacus does place value very easily. So we have the ones, we have the tens. On these blocks, we show that this is a 10, but it doesn't show actual place value, right? 1, 2, 3, 4, 5. I have 50 here, right? If I have 50 on a place value, that's what 50 is. It's good to see the abacus. It's good to see the quantity, but on the abacus, it's also how we write. So that was the other thing is writing. So we have our singles, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So we have 10. So when we add 1, we add this 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then that's 10 too. That's 10 as well. And then we have this, right? This is a 10 by 10. Yeah, 10 by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 6, 7, 8, 9, 10. So it's a 10 by 10. This is 100. And so on the abacus, this is 100. 1, 0, 0. So these are nice because it shows the quantity, but it doesn't exactly explain the place value. So there's that. Um, so that's the dice, and then that's the understanding what supertizing is. And so supertizing helps. Just to reiterate, supertizing is to um, make sure that the kids know what the number is. So when I do this, they know that this is number 4, right? If when you do this, you know that that's 5. That will always be 5. And then yeah. Oh, so and then that was interesting. Like I was thinking about playing cards, and I kind of like playing cards because it shows you the quantity 1, 2, 3. On the abacus, that's what it is. And then if we do and it's cool, right? Because playing cards has the different suits, right? So we have suits. Why am I showing this? Because I think playing cards is more um mathematically interesting. Like it makes more sense, right? Because on the playing cards it shows you 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have to count 8, right? So it's easy. The in school sometimes they use playing cards to show the quantity. So when we do like 70, 87, right? It kind of the same. 87. So we have 80 and then there's 7. So on the abacus, it's easy to show place value because we have 87. In school, I don't know if they use playing cards in school, but I was noticing that Uno's different. If you notice, Uno doesn't have any items, so it's difficult to see the quantity. When children play Uno, they have to know the numbers. They have to know that this is 7, right? As opposed to a playing card that this is 7. 1, 2, 3, 4, 5, 6, 7. Like they could see it and they can count it, right? But they have to know what 9 is, right? And on the abacus, that's 9. So it's easy. It would be nice if you ever play Uno, you can use Uno, and if they're having problems to see what the numbers are in Uno, you can use the abacus to help. So if I do 8 or if I do 5, right? 5 is that. And then you can match it with the playing cards. If they have problems with understanding what the numbers, because numbers is really just a symbol, just like the letters, right? Letters are like A, B, C, D. all together, by itself, it doesn't mean anything, but you have to put it into a word. So you say like cat, CAT. Those are three symbols, but you put it together, it makes a word. Where it's interesting because the number itself, we know it's a quantity. Like it can be by itself five. Five is a five of items, right? It can be five of hearts or it could be five of diamonds, but we know that that's five. The idea of the five is a symbol, just like the letters, but there's more to it than just, there's more to it. There's more um, foundation to it. So it's good to be able to know the numbers, to be able to get to know the numbers. So that is the playing cards, and then the difference of Uno. So then I have an online class. Where are we? I have an online class. Ooh, 21. Okay. So I have an online class. It's about I mean there's two levels. There's one level where we start doing the just preschool stuff, whereas like we do counting on, we count backwards and we figure it out. So in the beginning of all abacus class is knowing how to read the abacus. So in my uh level 1 introduction to abacus, um hi Jennifer. Um, in level 1 in Abacus, in the introduction to preschool as well, we talk about how to read the Abacus. So I have it where I have exercises. I have it where I have exercises to read the Abacus. The reason why is because it's not a common thing to understand how to read the Abacus. But once they know how to read the Abacus, then we could go further on and we could start. We could in the preschool when we do counting on. In level 1, I'm assuming that they know how to count. So the only thing that they need to do first is learn how to read the Abacus. Once they read the Abacus, then we can start doing adding and subtracting. And adding and subtracting is towards the end of the preschool book, but it's the beginning of the introduction one. So um, the way I have it is we do adding and subtracting. And I break it down to like the specific numbers. The reason why is because I want to show um I want to show what it's like um to move the bead. So if we have 1 and 1, so we're just moving this 1, and then we have 2, and then there is so if I add one more, there's 3, right? We're moving this bead. So if I take away 1, it would be like that. And then if I take away 2, it'd be like that. The level 2 would be doing multiplication and division. But the first thing we're going to do in level 1 is we're going to go through all of adding and subtracting. So um I don't know if so what we're going to do is we go through this addition table. Can you see that? So the first thing we're going to do is, no, that's not good. There. How about that? Okay. So in school, we actually do the addition table, right? But if you notice in the addition table, they just kind of give you the whole thing and they'll be like, here is an addition table. But in Abacus, it's kind of interesting. We actually break it up. So in level 1, we start doing like adding. I don't know if you could see that. I should make it better. There we go. So in Abacus, we actually do the first part. So in preschool, we start doing these adding, right? And we break it up. And then did I print it? I don't know if I printed it. Oh, I guess I didn't print it. I must have. Nope, I didn't print it. Okay. So anyways, back to this. So in preschool, we're going to actually doing adding and subtracting here, right? And then in level 1 we go into adding and subtracting these ones, and then we go in, and then after that we start going into adding and subtracting these numbers. What does this all mean? Why am I showing you this? Because there's a system. It's systematic. And so after we learn how to add and subtract on the abacus like this, from 9 plus 9, we don't learn doubles. What we learn is the fundamental building blocks. So after that, we actually do multiplication division. Um, and so so when they go through level 1, we when they go through level 1, I actually talk about how to do cumulative adding and adding. So what is cumulative adding? Cumulative adding is when we do 2 plus 2 plus 2 is equal to 6. So we see this, so we need to know that this is 1, 2, 3. 3 times 2 is equal to 6. So this is all part of level 1, where they have to start learning their multiplication. Once they learn their multiplication, then we can actually use their multiplication in level 2. So what does that mean? Well, in level 1, we go to 9. We don't need to know anything above 9, because after 9, so like 2 times 9 is equal to 18, right? So this is something that we're going to have to memorize, because after that we do distributive properties, which is 20 10 sorry 2 times 10 is equal to 20. Well, on the abacus, there's a methodology where we start doing multiplication. Let's do 2 times 12. So on the abacus, we know that 2 times 1 is equal to 2, right? That is here. And then 2 times 2 is equal to 4. Whoa, 2 times 2 is equal to 4, and that's 4. So we don't actually memorize the 12 times table, the 12 times table. Why not do doubles? Okay, so we don't do doubles. Okay, so that's multiplication. Let me finish the multiplication. So multiplication. So on the abacus, we do distributive properties. And so exactly like we do 2 times 13, right? Oh, does that work? Okay, 2 times 13. 2 times 1 is equal to 2, and then 2 times 3 is equal to 6. So that is how we know 2 and then 6. So this is how we, and then obviously we get into more, so we can do like 22 times 13, right? This is all off the cuff. But thank you for your questions. Okay, so again, it'd be 2, but then when we do it, it's we have to also figure out place value. So when we do 2 times 1 is equal to 2, right? We go here, and then 2 times 3 is equal to 6. So we go here, and then we do it again, because we do this and then we do that. Maybe I should use a different color. So now we're onto this one, and we do it again. We do 2 times 2. No. 2 times 2, and then 2 times 6. So my answer is 286. 286. Okay. So now we don't do doubles, because doubles is a one-hit wonder. What does that mean? All right. So okay. Doubles. So in school, they're taught 1 plus 1 is equal to 2, which is fine. We could do that here, right? 1 plus 1 is equal to 2. Not a problem. We could do 2 plus 2 is equal to 4. Not a problem. 2 plus 2 is equal to 4. Okay. Now, it gets to a point where we have to do 3 plus 3 is equal to 6, which is fine, right? In school, they're taught doubles. But on the abacus, we don't do doubles, because we can't do doubles. When we try to do 3, so we try to do 3, and then we try to add another 3. Well, there's not enough beads to add the 3. This is in this book here, plus 5 with who. And Alyssa, I'm trying to get my form going so you can order it and it'll be delivered to you. All you have to do is pay for shipping. I'm just getting the form ready, and so then we can set that out for you. Give me till today, and I'll send that link over. Okay, but that's what this is. So what are we doing here? Well, this is where in school we learn what the 5 frame is. 5 frame. What is a 5 frame? It's where they, oh my gosh, 1, 2, 3, 4, 5. Sorry. This is the 5 frame. We know that 4 plus 1 is equal to 5. We know that 3 plus 2 is equal to 5. So this is great. This is fantastic. But the problem, not the problem, but this is the beginner level. In abacus, we actually take it to the next level. We actually take it one notch above. So we know that 3 and 2 are partners, right? If 3 and 2 are partners, what are we going to do? What are we going to do about that? We take this and we move it over here. Why? Why are we going to move it? Because in Abacus, we can add this 5, right? In Abacus, we can add this 5, but now 5 is too much. So we actually have to take away 2. So our answer is 6. Now, why are we going to do this a little bit more? Okay, well, let's take it one step further, right? We have 3 plus 3. Now we do 4 plus 3. 4 plus 3. Okay, so what are we going to do? We're going to need to know our doubles plus 1. You could do that. That's not a problem. Or you can go back and revert and remember this. Well, if I have 4, I know I need to add the 5, take away the 2. That's why we don't do doubles, because we do the fundamental building blocks, right? We could do it with 4. So we do 4 plus 4, right, is my double. Okay. But if you look, 4 plus 4, there's not enough beads to add the 4. So this is where we have to use our formula, our 5 frame. And this is where it becomes more versatile. So we have 4, we want to add the 4. So what we need to do is we need to add the 5, but we have to take away the 1. And my answer is 8. That's 8. 5, 6, 7, 8. Now, um, if we do 3 plus 4, maybe I should do 4 like this, right? 3 plus 4. Well, you could do, again, you could do your doubles and then minus 1. 4 plus 4 minus 1. You could do that. Or you can go on the abacus and be like 3 plus 4. Well, plus 4 is equal to 5 minus 1. This is a common formula that is used in abacus all over, everywhere, everywhere, everywhere. So we know that 4, we want to add the 5 and take away the 1. This will always be the case because we can use it here. So on the abacus, there's sets of formulas that we have to memorize. This is more building blocks, but we actually take the 5 frame and we make it use it in advanced steps. So that's why we do it. So then let's go to 9 plus 9. Well, 9 plus 9, 9 plus 9. Well, same thing, but now we're using the 10 frame. Oh my gosh, I have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so in the 10 frame, we know that 9 plus 1 is equal to 10, right? We know this. Okay, that's what is being taught in school. Not a problem, not a problem. But now, how do we use it in the abacus? Well, if we do 9, all we got to do, and the concept's the same. Once you understand like the fundamental concept, the concept's the same. We just need to move this over here. So just like we did it for the 5, we can do it for the 10. So we add the 10 and we take away the 1. And that's why we do it. That's why we don't do doubles. It's a little bit but it's a little bit more, but learning doubles is like a one-hit wonder, if that makes sense, right? As opposed to, learning the fundamentals, learning the building blocks, and then being able to manipulate it. Because once you get to like 20, 28, no, 38, let's say we do 38. We do 38 plus 9. Well, you could do your doubles, and then you could do your counting, right? Which is fine. Or you can just take your 9 and we do plus the 9 is equal to plus the 10 minus the 1. Oops, sorry, right? Plus the 10 is plus 9. So we're adding 9 to this, right? So it's plus the 9 minus the 1. I'm sorry, plus the 10 minus the 1. So my answer is 47. So it's a lot about just moving the beads and making sure that it is that it matches. So when we learn the formulas, it's about moving the beads, how to move the beads so you could see it. So then the idea is once the children sees the abacus and they see how it moves, the reason why we go through the motions, it, we go through the motions so one, it's muscle memory, and two, they could see it. So then when you remove the physical abacus, they can actually see it in their brain. That's the idea for mental math on the abacus. I have 3 boys, and they've all gone through the, Abacus, curriculum, and a lot of it is just they can't tell you they can't tell you, um they can't tell you what it is, but they can move the beads if I give it to them, if that makes sense. You know what I mean? So, anyways, so that is, so going back, so that is about learning the 5 frame and the 10 frame, and that is being taught in level 1. The reason why, and then it goes into the reason why, and then I doing this also provides analytical skills, right? So in Abacus, we actually have to start counting, not counting, but we have to start going through a checklist. Okay, can I do it here? No. Can I do it here? Just like what we did for 4, right? So we start them early saying, okay, analytically, how do we do this? 4, do I have enough beats to plus the 3? No, I don't have enough beats to plus the 3. And I don't know if school teaches how to analyze what we have. They're just taught to just do it, right? But on the abacus, we innately it's part of the system to ask, can I do it? Yes or no? So this is yes, it is a gradual what lesson? Uh, so this is a gradual process. What lesson? What are you talking about? Alyssa, I'm not sure what you mean by what lesson. So I have my class is broken up into every worksheet is a video. So I've created like a whole bunch of I created all these worksheets to help the children to be um engaging, entertaining to do, right? As well as still making sure that they learn how to do the abacus. So in level, so this one where we do the +5, there is instructions, right? How to add the 5, and then how to add the 4. There's the questions to strengthen, to enforce what the 4 is and how do we use it. I This one is where we go to the cats in the tree. So the idea here was to because some kids don't understand what this 5 means, and so I added it into a story, and I had it where if I want to add the 1, so I have 1 on the abacus, now I want to add 4, right? So we have to go to the tree. This is the tree, and then we grab 4 cats, but then 1 cat runs away, and so we're left with 5. So that's the idea of this one. This is a module, and in the module has multiple videos of all of the uh, of all of the pages. Not all, like all of the big concepts, and then there's extra pages if you want to continue on. So this one is like a hidden word. You answer the question, and then you try to figure out what the word is down here. I have a maze where they can figure out what the number is, and then because of the number they have to figure out where the answer is. So this is what I've done, and this is what my class is. It's a bunch of it, and I have it where I create all these worksheets. I have more, and we doing right now we're doing a +10, -10, and then we're going to be doing mixed. So it is a graduate. It is an investment, and that's why each page. I mean, you could do 1 page a day if just to keep them active. I don't My goal was to get the kids to be comfortable with counting, adding and subtracting, multiplication, division. My goal wasn't to make sure that they were competition ready. There are abacus competitions, but I felt like that they needed to be more entertained, more engaging. So I created these worksheets. These worksheets are not, they're, nobody else has created Abacus worksheets that I've seen. They've always just been like a bunch of numbers. I don't know if I have a picture of it. Um, but yeah. So um, then after they learn how to do the adding of the 5, there's a minus 5. So after minus 5, there's a plus 10, and then there's a minus 10. Let me go get my minus 10s, my plus 10s. So here is examples of plus 10s. So I have it where we talk about the 10 frame, or the number blocks, right? The number blocks of the 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then from here, they need to see that there's the 7 and the 3, and 7 and 3 is a pair. And so, and this is what's taught in school as well, right? But then we take it to the next step, which is we actually utilize it in a no we utilize it in a, where's my paper, there we go. We actually utilize it, and when we do the 10 take away 3, or 21 take away 3, we use it on the abacus. I don't know if that made sense. So yeah, and then I have it where these are all the activities that I have. So these are the activities that I have and that I created. Um, they're all from my they're all from my brain. um, but the idea was to introduce like the numbers slowly, so then they start learning how to function. And once they learn it, once they understand how to move the beads and understand the formulas, then it'll be easy for them to be doing adding and subtracting, multiplication and division on the abacus. And that's it. Can you show 21 minus 3? Oh, okay, yeah. 21 minus 3. This is, so it's the same thing, right? So 21 minus 3, right? Now, what is the family of 3? Okay. 1 2 3 1 2 3 4 5 6 7 8 9 10. I think that's 10. 1 2 3 4 5 6 7 8 9 10. Okay. 21 minus 3. The reason why this is a beautiful question. Why? Because remember we had the 5 frame, and this is where the analytical happens, the analysis. And this is really beautiful when the kids like catch it. But it's the idea of it. So the first thing we need to do is we need to add 21, right? We have 21 on the abacus. Now we have to take away the 3. Now when we take away the 3, we have to do a few things. Can we take away 3? No, we cannot take away 3. I'm not showing it. Sorry. Can we take away 3? No, we cannot take away 3. So this is where the analysis happens, right? Let me move my stuff so it's easier to like. And this is where it gets exciting. So we have 21 take away 3. We cannot take away 3. So one thing we need to do is we know raise yeah. Um so here we notice we cannot take away 3. Can we? Okay. So the next thing that we have to do is like, is there another way to take away 3? Well, remember when we did the 5 frame, right? The 5 frame is minus the 5 frame is 1 2 3 1 2 3 4 5. So 5, right? The 5 frame. We have 2 and 3 is equal to 5. Well, now the question is, can we take away the 5 here? No, we can't take away the 5. So we cannot use we cannot use this concept. We cannot use this building block. So the next thing we have to do is we have to do the 10 frame building block. So what is the 10 frame? Well, remember 3 plus 7 is equal to 10. So if 3 plus 7 is equal to 10, I need to take away the 10. So now we're going into regrouping, but in Abacus, we don't call it regrouping. We just use the formula. So here, It's when we have to take, this is my equal sign, we have to take away 7. So when we rewrite it, it's minus the 10 plus the 7. Why? Because I want to take away the 7. I want to take away 3. Okay, so I want to take away 3. So the idea is I want to take away this 10 and I want to add 7. So that's the next so when the class goes through, the first thing that they need to do is understand how to add the 5, then they have to minus the 5, right? Then they add the 10 and then they minus the 10. That's the order, the framework that we go through Abacus. So it's easy. I mean, in school, right? You have 21. You're given 21. So then what do you have to do? You have to regroup it. You have to, oh my gosh. I don't teach this in my class, but this is for more, for you to understand. So regrouping is 1 2, so we have to do 10. So we have to take this and we have to break it apart. So if we break it apart, it would be 1 2 3 4 5 6 7 8 9 10, right? And then we take away 3. So this is what they're teaching in school, which is great. I mean, the kids can see, but it's a little, I feel like it's a lot. It's a lot to like take in. On the Abacus, when they know this, they know how to do it. So if they do 22, right? Again, so I increment it. So 22 take away 3. It's minus the 10 plus the 7. Minus the 10 plus the 7. Ooh, 7. And that's it. I hope that makes sense. But it was a lot more to, I mean, there's a lot to it. It's not as simple. School doesn't make it simple and math is not simple, but when you know the building blocks, it's simple, if that makes sense. So I hope that makes sense. Um, but yeah, I don't teach like regrouping with these number blocks. I teach regrouping on the abacus. So in school, they're probably taught this, and I would recommend that they learn it from school as well, and then they can use this and they can supplement with abacus. My kids all learned abacus. They I still tell them that they need to show their work. So just because they know how to do the abacus, they should still need to show their work. Sometimes you can ask the teacher if it's okay to bring the abacus to school. My teachers, my children's teachers, they were okay with my kids bringing the abacus to school. So but I would ask them to see, if it's okay to, because it's a tool, not a specific electronic calculator. The reason why is because it helps them keep track of the numbers. So it's not as it's a mechanical calculator, but what it is it keeps track of the numbers. And there was one where there's this one student we had. He went to college and he was in a science class, and the science teacher was like, so the building blocks are knowing the partners. Yes, the building blocks is knowing the 10 frame and the 5 frame. Yes. Um yeah. So in school we are taught this, right? We know what the number bonds, right? We're taught the kids are taught number bonds. 4 and 1 is equal to 5, right? Or 3 and 7 is equal to 10, right? They're taught this. But on the abacus we take it one step further. So, going back to my story. So my student, he goes to college. I think he was at UC Berkeley. And one of the science teachers was like, you know what? Nobody's allowed to use the calculator. Nobody's allowed to use an electronic calculator. And he was so excited. He was like, great, I get to use my abacus. So he was able to use his abacus on the in his science class, because it helps to keep track of all the numbers, but you can do multiplication division on the abacus. So yes, but yeah, so going back to the building blocks, yes, knowing, but then that's the thing, like we really know that it's called addition fact family. So we get it to where we really know the addition fact family. Um, Addition, fact family. So these are all verbiage that I had to learn to connect. what we learn in school to what we learn in Abacus, and they're they're so similar. It's so similar. Like, I was really surprised. But going down this journey of like building my books and trying to make it more mainstream. So learning the fact family of fives and learning the fact family of tens, it goes to the next level. So, and then I don't know if there's such thing as a subtraction. I would assume subtraction fact family. So the fact families are what? 4 plus 1 is equal to 5, right? 3 plus 2 is equal to 5. And then the other fact family is 1 plus 9 is equal to 10, and then 2 plus 8 is equal to 10, and so forth. So yeah, but see, the interesting thing is they stop at right there. In school, they stop right there. They don't take it to the next level. Whereas in Abacus, they take it to the next level, and that's where you add in the fives and the tens. And then the next one is where you start combining the two. And that's a little bit more advanced, but it's there. I mean, the building blocks is those two fact families. And once the students understand the fact family, then it's easy for them to be able to manipulate all the numbers. And it doesn't matter how big the number is, right? It could be like four digits. I don't know, 4, 7, 3, 8 plus. You know what? I should find let me find example. Let me see. Um, okay, so here's an example. So here's an example of like more. Oh, there we go. Here's an example of like the questions that can happen in Abacus. I don't know if I definitely for sure know that they don't do this in school, right? There's not 1, 2, 3, 4, 5, 6, 7, 8. I don't know if I'm going to do for, um, I don't know if I'm going to do eight for my class. It depends. Okay, here's full transparency. I'm starting an online Abacus class, and I wanted to make sure it was more mainstream is than what it is right now. A lot of it, people think that Abacus is a separate subject, and it's not. It's math with an abacus. And what I'm trying to do is um, I'm trying to bring it to the American culture. Everywhere else in the world, they know what abacus is. Like, I have people following me from like internationally, like from Africa, Uganda, and some people from Turkey. There's a bunch of people. There's like a class in France that's using my abacus book. They're not in my class, but they're using my book, and it's just to bring it together. So why am I saying this? Well, I don't know if I'm going to do this in my class because that's part of competition abacus. I might do, 4 lines for class, and then that might be it. I don't know yet. I haven't figured it out. I have heard of Beast Academy, but I've heard of it, but I haven't studied it. Like, I don't know what they're saying about it. I don't know why they would do partners to 20 because it seems redundant. Anyways, so here's an example of like a level. Like, this is the top level. This is one of my kids when I did it. When they went through the really the really boring abacus curriculum. And so we actually do decimals, and this is doing times. I don't know how pertinent it is to do decimals on the abacus. So that's why I'm like questioning how far to go with the abacus classes. Because after a while, like, once they understand their decimals, then they can I think by then they can actually start using a calculator. So I'm still kind of questioning like how far I want to go with the actual online abacus. But I do want them to a point where they can do this in their head. That's the idea. This is what they can do in their head. So we'll see. But I do appreciate you. This is like full transparency. This is where I'm at with my online class. So on the online, this is my brick and mortar where we actually teach how to do this in person. But I think I'm going to take it to one step different when I do it online. So, but I will take a look at the Beast Academy. Thank you so much for letting me know about it. Um, oh yeah, so then this is what they can do in their head. Can they really do it? I mean, it they still need to write it out, but they can do it without the abacus, and that's the idea. I mean, but there's more to division. Um, yeah, math is all about patterns. Oh, I love it. I love it. This and wait, but that's why I take it slow for the kids to learn how to do the patterns because they could see the recognition, right? So two beads, right? And then if I have two beads, this is another two beads. So they take it. These are two beads, right? Oh, I don't know if you can see that. So, but yeah, it's all about patterns. And and the interesting thing about abacus is that it brings in analytical thinking. So when you just get a question, it's not just here, add a question. It's can I do this and how can I do this? And I believe it adds creativity to their thinking when they start looking at numbers and questions. So, but yeah. So I'm so helpful. I'm so happy that this helped you. Let me know if this helps. Hashtag replay if you're watching this. But it is. But learning math with an abacus, learning math in general, is an investment, and building a solid foundation. As long as I'm not here to push and I'm not here to rush the idea of learning math. It's a slow process, and you know what? Albert Einstein took a long time to learn math, right? It's not about how fast you can do it, it's how you can how it goes through. So, learning the fact family, we do addition fact family, we do subtraction fact family, we also solidify multiplication fact family. Then that's when we do the distributive properties, and with distributive properties we really solidify the idea, the concept of multiplication fact family. That's why they need to know their times table, in order to do the big ones like this. In order to do uh in order to do big numbers like these, they need to know their addition fact family. No, I'm sorry, their multiplication fact family. Yeah. So stuff like this, right? I mean, I could show you. It's not a problem. I could show you, but then I don't want to confuse you. But but again, so what we do here is we actually break this apart and we do one number at a time and we build it on the abacus. But again, make sure that the kids, have to show their work. I'm not here to say, don't show your work. You have to show your work because how is a teacher going to know if your child is doing the correct way? And in order to do that, we need to make sure that they understand to show their work. I have to tell my son all the time to show your work because teachers can't read minds, right? Um, so I'm planning to do this once a week as part of my membership, right? Thank you so much for joining. I do appreciate it. And you have questions, and any questions you have, I can go into and explain it better or explain it more, or even provide more worksheets if you're looking for it. What do you mean by show your work in written form? Oh, so so what it would be like some of the kindergarten. So we'll do kindergarten because it's easiest to explain. So when they're doing their adding, right? They'll do 7 plus, I don't know, 3. We'll do that. There's this one where they have called a math mountain. Showing their work is they have to, in school, my children's kindergarten teacher says, uh, you have to draw the circles. So showing your work is draw the circles. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So then they count. This is 10, right? This is what showing your work is, not just I know what 7 plus 3 is equal to 10 because I know it on the abacus. That's what I mean by showing work. Like they have to fully go through whatever the teacher is asking to show their work. So on the abacus, you could show your work, but the teachers might not understand it. What I'm saying is when I say show your work, whatever the teacher's asking, show it. There's, you could do it through the Abacus way, or you could do it through, you could do it through the Abacus. You could do it through the Abacus way to double check your answers, if that made sense. Um, yeah. So, I mean, there's a lot of strategies that happen. Yeah, it is a lot easier on Abacus, but obviously not everybody knows it. So that's why. So not so the teachers will provide strategies. There's other strategies. I can't remember. Anyways, there's other strategies. They talk about building a 10. Um, there's another one, yeah, like build a 10. Oh, how do you find ways to build a 10? It's like you could build a 10, not a problem, or you can use the fundamentals of plus tens and then add it. So like this one is for uh, I don't know, 3 to, I don't know. Now I'm just trying to figure out, like, so you could build this as a 10. One of them was make this a 10. I don't even know how to, I guess I should research on how they build a 10, but like the idea is make this into a 10, so you have to borrow it from somewhere, and then so forth and so forth. Whereas on the Abacus, if it's like 8 plus the 1, and then 3 plus 1, and then 7 plus 2. Oh, anyways. So yeah, there's, in school they give you so many strategies, or you can use the Abacus and just use the fact family, like solid fact family. So it takes a while to get it, but once you go over the hump of saying, oh, this is why I'm using it, then it goes like really fast. But it takes a while for the investment. It is an investment, and it does take time. I'm not saying it's easy. It does take a it The kids don't understand it, but then if you repeat it, just like practicing, just like a skill, they will get it. But it's a lot about practicing and just, staying with it. If you could do 1 page a day, 20, 10 or 10 questions or what have you, I try to make it 1 page a day. Just, it should take them less than 10 minutes. Just 1 page a day, just to keep track of, not track, but just to keep the Abacus, you know, in their head. So that's my thought. I mean, when I did it, I had my kids do like 5 questions, well, these type of questions, it was like 5 questions, like 2 questions a day, but there was like a lot of them. In the beginning, like this stuff, like if they could do 1 page, they should be able to do this in 1 page without a problem. And then when they understand their fact family and become solid in it, then that's where the quickness comes in, right? That's when they're like super fast. But it takes time to get there. It cannot be happen right away. It's not a quick fix. It's a slow progression, but once they get it, it will be fast for them. So that is my time. I don't want to be over, and I just want to let you know that Alyssa, I hope I'm saying your name right. I will get that ready, that form for you. For those, this is available on Amazon. This is also available on Amazon, but since Alyssa, you're in my class, you get it for free. You just have to pay for shipping, and I'll get that ready for you. Thank you again for joining me. I hope this was helpful, and I do plan to do this a more of a regular. I do plan to make this more regular. So then, if you have any more questions, or if you want to know what's further on, I'm so happy to help, and I hope this makes sense. If you want to have your child to watch, I'm not sure. I can make it, like, not a problem. But um, it depends on, like, how to talk and stuff. This is more like for the parents or for teachers to explain, like, the benefits of Abacus. I should stop talking because it's like over 4 minutes over. So again, I'm gonna make it more regular. So if you have any questions on, like, of the activities or what my thought process was, this was, oh, anyway, sorry. You know what? I'll do that in the next video. So I will be back again next week, and come come with any questions and I'll be happy to explain my activities or the concepts of Abacus, and we'll go further from there. Thank you again. I appreciate everything and I appreciate all the questions, and I will see you soon. Bye.